I see some folks have come to the meeting already, and we probably can get started. First, can someone please in main chat if you can hear me well? Okay, great. Thank you. Right. So today we have two rather small caps to go through. Both caps are about adding some new host functions for Soroban, and both are pretty simple, so this hopefully shouldn't take too long to discuss. The first, okay, maybe let's wait for it 30 seconds more. See folks keep coming. Right, I can see no one has spent some people even. Okay, so let's get started. Right, we have CAP-68 first, and CAP-68 proposes to add a new host function that will be used to get an executable for an address. And depending on what the address is, the executable value will be different depending on what the address represents. More specifically, when the address corresponds to the classic account, there's technically no contract or no executable for it, which is why we'll return special value that says this is a classic account. Now, when the address corresponds to a contract, there are also two different cases. One case is when the contract is a stellar asset contract, which is our built-in contract, and in that case, again, you will get the flag that says that this is a stellar asset contract. And when you're dealing with a regular WASM contract, we'll tell this is a WASM contract and provide the respective hash. This is actually both specification of the CAP and quick description of the CAP. So there isn't much to talk about here, but I guess there is quite a few things to tell about motivation for why would someone actually want this feature whole and why this hasn't been implemented initially in the protocol. So in general, addresses are kind of abstract, right? You can, for example, call require auth for any address, and in the background we will figure out what exactly to call for it, or you can save the address into storage, for example, and you don't care exactly what backs this address. But there are some more narrow use cases which kind of came up during the time of Soroban's existence, and they're kind of different in their ways, but the common topic is, well, some information about the address is necessary to be retrieved. Specifically, one of the use cases which has been brought up is about distinguishing the custom tokens and stellar asset contract tokens. And the way this function will help is that you will be actually able to tell on-chain if a given contract is a stellar asset contract. And then, for example, you can look up the contract name and see which classic asset it corresponds to. And you actually don't need to worry about, like, if you know the executable is a stellar asset contract and you know that its name is, for example, native, right? Then you actually are 100% sure on-chain that the contract you're dealing with is actually XLM contract which has the name native, and executable Stellar asset contract. And the same goes basically for any assets, and this use case has come up in the context of the Accelerator bridge that does some cross-chain token wrapping, and basically in order to deploy a token on a different chain, they need to understand like if it is a classic token they're dealing with, and thus they can create appropriate metadata for this event. And there is no need to hard code, for example, IDs for all the contracts. And I think the question of what is the address of the XLM contract, or how they figure out if something is XLM, has come up quite a bit before, and now we provide a way that doesn't actually involve storing the hard-coded XLM value, which may be valuable in some cases. Another use case that has come up, I don't know if Tyler is here, but basically when dealing with the custom accounts, there are maybe several actually quite different cases for why you would want to know specifically what is the hash of a particular WASM contract, what is the WASM hash. And this may come up both in the implementation of the custom account itself, say you want your custom account to only authorize token operations on some trusted token implementations, right? Again, for example, Stellar asset contracts plus certain trusted custom token implementation. Or maybe in general you want to be able to verify the source of certain contracts you want to interact with, right? It is more of a customization thing. And another case that Tyler has brought up specifically is that if you wanted to build some modularized accounts that have several contracts implementing several different authorization policies, which kind of makes sense for the general custom account customization. You basically may have some contracts that would do auth for you, and you actually want to be confident that this contract will not be updated. So for example, you trust certain contracts to do something on your behalf, and you trust its current implementation, but you do not want this implementation to be ever changed. And if you know what is the current hash, you can actually enforce that and enforce the hash and make sure that the hash hasn't changed in the future invocation. So all in all, these are like pretty narrow cases, so it probably doesn't come up for each and every contract, but I think they are interesting enough, and in general, functionality like this makes sense to provide it like a counterpart of the deployer function, right? You can deploy something, but you cannot know what exactly has been deployed. Now we can do it in another end of this, and I think beyond what I've been talking about, there are some other things that people may come up to if this function exists. It is not something unique to Stellar, for example. Right, I can try to speak louder. Is it better? Okay. Okay. Yeah, I should have pinged me sooner. Yeah. So what I've been saying is that the use case presented in the CAP and the discussions are some of the use cases that motivated this CAP in the first place, but I'm sure there are more things that people may come up with, and this functionality is not unique to Stellar or Soroban. For example, EVM has functions for retrieving actually, they even have functions to retrieve the entire code, which I don't think is relevant to Soroban, but also like to retrieve the hash of the contract code, which is more or less what we are doing here. So I think all in all, it's pretty sensible idea to have, and some use cases where this is helpful. So this is pretty much it on the CAP presentation, and I don't know if there are any questions, but there was a discussion in GitHub regarding the data structure to be used here, because the initial CAP has nested data structure proposed, and Leigh has suggested to use a flat data structure. And I think I haven't replied on the discussion, but after looking at this again before this meeting, I think it seems like a sensible suggestion. So I'll probably update the CAP and make the enum structure flat. Yeah, so it's like a small implementation detail, but I think it probably makes sense to do that. Yeah, so that's pretty much it on CAP68. Are there any questions? Yeah, regarding the flattening, yeah, I agree that even though we are kind of going to have two very similar data types, I think it makes sense conceptually to have this flat. And I guess it's not too much of a maintenance burden. Yeah, I agree that not for performance reasons, but mostly for clarity. All right. Anyways, if anyone has any more questions, please post them in the discussion thread. Other than that, I think that's pretty much it for CAP68, and now CAP69. It's an even simpler CAP, and it simply adds two conversion functions: one to convert string object into byte object, and another to convert byte object back into string object. And the reason for this is basically that string objects. Well, first thing is that strings and bytes in Soroban are exactly the same thing. So it kind of makes sense for them to be convertible to each other. But the main reason for why this has actually come up is that due to, I guess, a bit of an oversight in the design, string has very restricted set of the host functions that can do anything about it. Specifically, like you can get only string lengths today and copy it into guest memory. So people were trying to get, for example, a character of a string object, and that's not possible without actually copying the whole string back into guest memory. And if you don't know the length of your strings, then you need to link alloc or do some weird hacks where you would only load some slice or something. So basically, it's all kind of hacky, and just adding the conversion functions is a very quick fix for that. So you can convert string into bytes on the host side, perform any of the operations that are already available for bytes, and then maybe either convert it back or I don't, depending on your logic. So yeah, I think it was mostly design set. I don't think there is a great reason to not have it. And also this has come up actually about a year ago for at least once before, like recently. And again, people are just confused why there is no conversion between bytes and strings. And well, you can just add it. It's a very simple change. So I guess that's all I have to say for this cap. Yeah. So if there are any questions, again, please let me know, or please post them in the respective GitHub discussion. Right. So that's it for me. I don't know if someone wants to use this time for CAP-67 or not. I don't know. But yeah, that's pretty much it for me. And if no one else has anything to talk about, then you can call it a meeting. Okay, it seems like no memo discussion for today. And I guess that's it for this meeting. Thank you, everyone, for attending.